In seismic retrofit work, we don't look at Richter scales. In other words, we're not trying to resist a 7.5 or 7.3. We don't design around that. What we design around is a ground acceleration. So we have an anticipated ground acceleration here in the San Francisco Bay Area of 0.186 Gs. And that's what we need to design against, and I'm going to show you how that's done. So what we have here is the ground acceleration is pushing at the base of the house just like this. So what's happening is the ground is moving this way, and inertia is causing this house to lean, and it's going to want to try to slide off the foundation right here. So in a seismic retrofit, we're trying to prevent that from happening. So I want you to notice how this movement right here, underneath the house, is identical, at least what happens here is identical to a force that is pushing on the house right here. So what we do is we figure out the weight of the house, and we have the ground acceleration underneath the house. And when we multiply those two together, we end up with pounds of force. So we look at, we translate that ground acceleration into pounds of force that are pushing against the house. So all the hardware and plywood and whatever it is that we happen to use in a seismic retrofit is designed to resist a certain number of pounds of force. So we have pounds of force that are pushing against the house, and then we have pounds of resistance provided by the retrofit hardware. So let's see what this understanding of earthquake forces looks like in actual practice. So a foundation anchor can resist 2,000 pounds of earthquake force, and then we'll have shear transfer ties that can resist 1,000 pounds of earthquake force. Now this is only for educational purposes. Foundation anchors, it depends on which ones you use to figure out how strong they are. Depends on the species of wood, just depends on the particular foundation anchor. Now the same thing with the shear transfer tie. It depends on the species of wood, it depends on the type, and there are quite a few. So this is just for educational purposes to see how earthquake forces and design principles work when looking at a house. So now we have 10,000 pounds of earthquake force coming in this direction, and we need 5 foundation anchors to total that 10,000 pounds. Then we need 10 shear transfer ties in that same direction to resist 10,000 pounds. Now for 10,000 pounds going in the other direction, it's the exact same thing. We need to have equal resistance on all sides of the house, because you never know how an earthquake is going to attack a house, and the code basically says you need to have equal resistance on all sides, because you don't know, which direction is coming from. So that's how a retrofit works. We just say a certain amount of force is going to be pushing on the house, and we have foundation anchors and shear transfer ties that can resist the amount of force, and they are rated in terms of how much force they can resist. So now we need to figure out how much earthquake force is going to attack a house, so we can figure out how many foundation anchors and how many shear transfer ties we're going to need. So what we do is we use engineering calculations that are the basis of an engineering guideline called Standard Plan A. I happen to have been on the committee that wrote Standard Plan A, and I have the calculations. I believe I'm the only one who kept a copy of the calculations. I did put them on the web, and you can see them right here behind me as I scroll down them. And so they actually go over the weight of the house. They go, what was was it made out of stucco on the outside, or was it wood? Is it plaster on the inside? Is it sheetrock? Is it 1-story or is it 2-story? What was the year of construction? All sorts of things. They go, what was the roof made out of? They go into all sorts of things throughout how much houses weigh. So we take that number, we multiply it by a ground acceleration, and that was in the 0.186 Gs. And that was a number given to us by a geologist who was on the committee. So we feel very confident that when we figure out how much your house weighs, and then we figure out how much earthquake force is going to attack it, that we can then put in the proper number of shear transfer ties and foundation anchors to protect your house from the anticipated earthquake. Let's see what happens when we apply those engineering calculations to your house. The first thing these calculations tell us is that your house weighs 41 pounds per square foot. Now we take that 41 pounds per square foot and we multiply it by the square footage of 1,184 square feet. We end up with this number right here, 48,544 pounds. That is the weight of your house. Now we take that and multiply it by the ground acceleration that we just looked at as 0.186 Gs, and then we end up with this number right here. That's 9,029 pounds. Now just to think of it like this, there's a vehicle and it's right up against your house, against the floor, and the bumper is. And it also has a chain attached to it, and that chain is also attached to your house, and the bumper. But in an earthquake, what happens is it accelerates at 0.186 Gs, and then it goes in reverse at 0.186 Gs. So we have 9,029 pounds pushing it, 9,029 pulling on it, and that happens for the duration of the earthquake. All the time trying to dislodge your house, push it off, pull it off, whatever you want to call it, from the foundation of your house. And we want to make sure that doesn't happen. So as we just noticed, every piece of hardware can resist a certain amount of force. We want to make sure we put in enough to make sure this doesn't happen. And what we've done in your case, if we've actually put in enough hardware to resist 18,360 pounds. Now, the reason we've done that is we want to make sure that you feel 100% safe. Retrofits are expensive, and we want to make sure that you get what you pay for. We want to make sure that if you're thinking about earthquake insurance, or should I have it, shouldn't I have it? Well, if you have a good idea of how earthquake resistant your house is, that should help you make that decision. And finally, we don't want to get a phone call from you saying, you know what, I really wish you'd done more. So we want to make sure your retrofit is as bulletproof as possible. Now let me tell you how these letters work. So if you see this letter here where it says letter A, you would come down here and then you would see along one of those foundation lines where it says A, we install 3 foundation anchors in any combination of these shear transfer ties to equal the 18,360 pounds that we need. So if you look here, all these different locations, if we install the hardware specified for each one of these locations, then our entire retrofit will resist 18,360 pounds of earthquake force, which is about double of what we need. But there's good to you never know. A little security, extra security is always a good thing. Now if you come over here, you can see these are the capacities of the shear transfer ties that we'd be using. It could be, I'm not sure which ones we use until we get there. We just got to make sure that we have enough to equal the anticipated earthquake force. These are the foundation anchors, and in case we have to use the plywood, we can use this right here. That's our values, depending on if we find it. We need to know the capacity, otherwise we can't really do a right retrofit for you. So anyway, that is what your retrofit consists of, and as long as all these things happen, your house will be fully retrofitted.